Right, this is a 3D video. Again, you're going to need to put on red-cyan glasses to be able to see it in its full effect. Now, remembering back from our vector equation of the plane, we go from the origin to a point A, some multiple of AP, and then some multiple of PR, where R is a general point in the plane. And you'll see, if we move this around, we can get every point in the plane. Now, in order to get the write it in a Cartesian form, we need to first of all write it in the normal vector form. So let's just put these back at 1 and 1. Alright, and what you will notice here at this particular point here is that there is another vector which is like the normal to both to the plane, okay, and it's like normal to AP and AR. Let's just click this here. So general point in the plane, OR, O to R is the same as going O to A, lambda times A to P, plus lambda times P to R. Now, what you'll notice is that the normal will actually be perpendicular to both the vectors AP and PR. So if I click here, the normal vector will be the vector product of AP and PR. So in this case it's minus 28, 56, 84, and this is why it doesn't have an arrow on the end of it. It's gone right off the end of the out of the scale of the problem. Okay, so you can see this vector, this normal vector here. Alright, and if I click, you'll get the normal vector equation. You need a particular point in it, in the plane. So we've got the point minus 7. We can take the point A. So if we know the point A here, okay, then we can do the vector equation of from A, P, cross PR, from there to there. We can take the let's just move that around a bit so we can see if I do an angle. Okay, so we need to do the cross product of this vector from there to there, and from here to here. So that vector and that vector we need to do the cross product of. Okay, if we do that in this case, the particular values, you get minus 28, 56, 84, which represents that normal vector there. Okay, and then if I have a particular point in the plane, which is that one there, which is at A, which is minus 7, 1, 1, then minus 7, 1, 1 dot the normal vector will give me that value. This doesn't represent the distance of the plane from the origin, right? So the normal vector can actually be simplified to something like this, because these can all be divided down to, and we should always use the simplest form if we can. 1 minus 2, 3 minus 12, and then because R stands for X, Y, Z, then the Cartesian equation will be 1 times X minus 2 times Y minus 3 times Z is equal to minus 12. If we move it, it will still be the same in its simplest form, but we just get different values for the normal because it's going to change. Okay, so that particular value is quite interesting because now you can actually see the normal vector. There. Okay, so remind you, so looking at different angles, Okay, this is a good thing is, and these GeoGebra apps are attached to these videos, so it's quite good. Again, remind you, you need to use red-cyan glasses in order to view the full 3D effect of the video.